here to present our project Morpheus for Control Plus Move Hackathon. Morpheus is a prediction market AMM built on Aptos that brings rigorous on-chain mathematics to a prediction market. So let's get into it. So why do prediction markets need a custom AMM? The current AMM models like Uniswap's CP models aren't built for prediction market as the LP losses spike as expiration approaches and at edge prices. Our model optimizes this through Gaussian score dynamics, which results in a reduction of average LP losses by a lot through a constant LPR. As you can see, our PMM approach has a constant LVR, while the other models have an unpredictable LVR, which causes significant losses to the LPs. So here comes our mathematical foundation. Our model uses Gaussian score dynamics and normal distribution to calculate invariants, which holds the foundation of our model, as you can see. So let's get into it through docs. So this is our docs. So let's get into it by knowing the foundational concepts. So the foundational concepts are the Gaussian score dynamics, which we talked about, which is a model for outcome token prices. We deconstruct the loss versus rebalancing, which is the expected losses the LP incur from adverse selection. So the first implementation of this philosophy is the static PM AMM. This model uses this invariant you can see here as the base for all the calculations. So for an economic intuition, you can see that a static PM AMM's liquidity is much more concentrated at 50% probability, which is good for any AMM model in a prediction market as the volatility spikes near the edge prices. The static PM AMM model, though good, doesn't account for the change in volatility with respect to time. So here comes our second implementation, which is the dynamic PM AMM model. What it does is it decays the liquidity with respect to time. So for an economic intuition, you can see that a static PM AMM's liquidity is much more concentrated at 50% probability, which is this innovation leads to a constant LVR across all the price ranges as well as the time of the prediction market. So as you can see here are mathematics, which you can find more in the paradigms research paper that we have linked there. All right, so let's get into the architecture. So these are the main modules our contracts have, which you can go through in our GitHub repo. So the high level overview is the user comes to the landing page where there are two options of creating a market or going to the existing markets, where the user can select a market and swap or add liquidity. This innovation leads to a constant LVR across all the price ranges as well as the time of the prediction market. So this is our swap architecture, which we have discussed about, which is calculated based on the invariant that we described before. Similarly, the mint token set infrastructure, which is basically a way for the users and LP providers to get the outcome tokens by providing a collateral, which in this case is the Aptos token. Similarly, for the add liquidity architecture, this also follows the exact same invariant that we described above. This is the mathematical foundation, as you can see here. The remove liquidity works exactly as similar to the add liquidity and the market resolution. A demo now. So this is the markets page where all the markets lie, as you can see. You can sort them based on liquidity, volume, ending zone, and newness, etc. So let's create a market for ourselves. Okay, so this is the create market form. So let's create a market, suppose at this version, and we'll have the same description. This belongs to the crypto category. Its expiration date is 30. Reciprocity is 40 for initially. Let's increase the liquidity as it is in Opta, right? We need a resolution source, so we'll copy the CoinGecko one to get the market prices, and we'll have a dynamic pool. As you can see, the market is created now, and it's going to get loaded here. Well, we have it here. So let's get into this market and see what it has. So you can see the current probability it is showing. The market closing in about a month created by me, the same address as you can see. All right, so we need to mint the tokens. So let's do that. Since it is in PPP, let's do this. Yep, that seems good. And you can verify that we have minted prediction tokens here. All right, now that is done. Let's move on to adding liquidity first, right? So this is our liquidity form. We provide the value in Octa, which is lower than Aptos by 10 to the power 8. So we need to provide a lot of Octa. So how about we do this, right? And as you can see, the preview here has quoted us the values which we are going to need for this. Um, let's do it. The values were in Apta. So, well, here you can see we have added liquidity here, and you can even go there and check the balances. Well, as you can see, we have minted LP tokens, which we can confirm from our wallet as well. Here is the LP token, the no tokens, and the yes tokens. So let's get back to it. Now that the liquidity is added, we can now trade the tokens here. So let's trade it. Okay. So we are going to swap some tokens of no for yes. So let's swap. As you can see, the values are here and the gas price is here. Let's do it. As you can see, we have swapped. For confirmation, let's go to our Aptos scan. Here you can see um, here you can see the byte yes tokens function has been called and the balance changes have been made. We are given 0.0001 amount of no and received yes tokens. So now let's check our balances. As you can see, we have much larger amount of yes tokens now than we had before and much less amount of no. You can confirm all the transactions that we have made in this demo. We'll put it up in the readme. Thank you. And this was our project.